curtains about to fall. We're gonna open your eyes so you can see who you're gonna call if you wanna be free. Globebusters! 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 Who you gonna call? Who you gonna call? Who you gonna call? Yeah! Globebusters! Globebusters! Globebusters!
And welcome everybody to GLOBEBUSTERS.
We accept the reality of the world with which we're presented.
And welcome everybody to GLOBEBUSTERS. It is Waves of Energy. It is season 9, episode 9. And we've got another great show for you. I'm your host for today, Jeran from Jeranism. And we've also got some panel members starting out with Dave Weiss in the house, DITRH, the man, the myth, the legend, the app slanger.
Welcome. Thanks for having me, and welcome everybody.
Very happy to have you. And we've got Zack. Zack Zabala, good times for all if you prefer. Welcome, Zack.
Hey, thanks, Jeran. Yeah, always a pleasure to be here for another GLOBEBUSTERS episode. Always fun when Dave's around too.
It is always
He,
fun when Dave's around.
yeah, he likes to push buttons, so it makes it fun.
He's been known for pushing a button or two. Maybe three. And we've also got...
This may or may not be true. I cannot confirm or deny.
Right. And we've got Skylar from Troubling Tribune. Skylar, what's going on?
What is up? Thanks for having me. Excited for an awesome show. Already got some high energy for it, man. Ready to dive right on in.
What else could you ask for, right? I want to show you something here real quick. Dave, have you seen that movie One Last Orbit yet?
No, I have not.
Okay, I'm going to show you guys something here and put it up on the screen. And this just shows you how intelligent these guys are because they actually proved the flat Earth wrong and mention it in the movie. So, I got to share my screen with you guys. Let me do that real quick. Share screen, and do I share it with sound? I think I don't remember if I share it with sound. I'm going to start without it just in case it gives us an echo. Actually, I'll try it. Do you hear any echo if I press play here? Oh, hello.
A little bit.
There is
Yes.
echo? Okay, let me start over. Stop sharing, confirm, stop sharing. All right, let's try it without the sound. There we go. All right, so now what screen do you see? This one here with the Earth in it? You guys?
Yeah, we see both little screens
Okay,
with
good.
the Earth.
Yeah, just making sure you see my OBS. All right, so we're going to listen to this. This is right when they're flying over the North Pole, mind you, the North Pole. And here's them about to disprove.
What they're going to do is they're going to have a new plane that goes a lot faster than we know, and they're going to do it a little better next time. I get so many people that don't understand the Santiago to Australia
Let's bring that up.
flight. So just real quick, if my grandmother had her car and she's going to drive from New York, from the coast, New York to let's say Salt Lake City, but I'm driving to go see Jeran in California, right? And I've got a brand new Beamer. I don't have a brand new Beamer, people. But is it possible that if we left at the same time that I could get there first? Is it possible?
Yes.
Okay. That's it. That's how simple, the flight, they're like, well, the flight from Santiago to South Africa, it takes the same amount of time as to Auckland, right? Well, they're going at different speeds. That's the simplest answer. They're going at different speeds, period.
Does anybody know it's so baffling that all these flights are in the north. Does anybody know what the flight number is, that the Qantas flight that we're talking about?
Hey,
Offhand?
I think we're off YouTube.
What?
Somebody said for policy violations or something. Cami just came in and let me know.
Yeah, we're kicked.
Oh.
Stream unavailable.
Oh, well, I stopped doing it, so it should come back. Let me see. Go over and
Okay.
check. Usually that happens
Because of that video? Because you're playing that video?
Oh, heaven forbid we comment on that video. It's a great video. It should never be commented on. It should just be played in full, in a theater, people crying. Look at the
But
speed.
it'll come back after you stop playing it?
Fair use.
Let me see. It should. Let's see. Error. Your stream has been temporarily blocked because we detected copyright audio and video. So what'll happen is once it realizes we're not doing that anymore, then it will come back. Usually that's what happens.
Tell everyone in the chat to just come over to put the Rockfin link over there. Just come over to Rockfin, everybody.
Yeah, let's just cancel.
Everyone that's listening to me
Let me go grab this Rockfin.
is listening on Rockfin.
Share, copy. Let's go see if it's in the chat.
Can't even comment on
Okay.
obviously.
Oh no, it's
fair
back.
use.
We're back. I see on the screen that it's
Yep.
the
Okay.
flights.
Yep. I see us on the screen. We're back.
All right.
I
But
found
next time
something.
that happens, people just come to Rockfin. Open up your Flat Earth Clock app if you don't know how to get there. It'll show you right now.
So don't you ever talk about that flight.
I think it was Qantas 14, by the way.
Thank you. That's kind of what I was looking for. Okay. There we go. Don't you ever talk about that flight. All right. Let's see. So you say it's Qantas QF. What is it? QF?
I thought it was 14, but I might be wrong.
Let me see here. I'll just go to. We can go flight by route. No. What's that? Oh, something. What does that say? Who just sent that?
I did. It's the only thing I found, and it's from the University of Wyoming. It says such low temperatures are not found anywhere else on the Earth's atmosphere at any level except in the winter stratosphere over Antarctica.
Oh, really? So it's saying that they get to what temperature?
I'm not even sure.
Let's see here if we can find this.
I didn't click into it. I just
Yeah, I'll
saw
have to
that
look into it.
picture and I was like, oh, what is this?
So that's their excuse then. Is there over
Nowhere else on Earth except for Antarctica.
And they
So the
flew
North
over
Pole,
it
it doesn't
during-
matter.
And why would they fly over it in the winter? Why not take that flight in the summer so we can see what's below you?
And doesn't that debunk the whole like airs has something to do with the the temperature? Because if it's Antarctica and it's got that, this is special. It's over Antarctica. I mean, it just doubles back to what I was saying about
It doesn't
the
make any
area the
sense.
sun was at would have a different temperature too.
The whole thing is a disaster. You're so right because also you said in the stratosphere. Is that what you said?
Yes. Yeah, the stratosphere over Antarctica.
Well, how high is the stratosphere? So it's really low in Antarctica and in the North Pole, I think. If you look it up, it's seven. I've done that before, right? Where I showed you that that's why I have the idea that I do about a cake pan, bundt cake pan, because the stratosphere, Wikipedia. If we look here, it's going to show that right here. So between the troposphere and stratosphere is the tropopause. Okay, that's the border. Near the equator, the lower edge of the stratosphere is as high as 66,000 feet. At mid latitudes, which would be 45, is 33,000 feet, and it says at the poles it's 23,000 feet. So then lowering the plane didn't do any good either, because unless they got below 23,000, that means that anything above 23,000 is considered the stratosphere. I didn't even know you could fly in the stratosphere. So I don't know, but again, they are just all over the place. But we can't talk about that; we get in trouble.
Live debunk.
Yeah, live debunk. Let me go back to my flight of where here. Okay, so I think it's. Oops, I was looking up what the flight was here. Sydney to Santiago. Where does it show the flight number? Come on, just show me the flight number. Sydney to Santiago. This is the flight. It's going 7,086 miles. Anybody see a flight number? Am I blind? I don't see any flight numbers. All right, well, let's just find it by going here and looking at the airports then. So we'll just go here. We'll go Sydney. Because what do they fly that plane every day? I believe so. Sydney.
Someone said QF64.
That might sound right. Let me see. QF64. Whoops. Let's see if that's it. Qantas Flight 64. This is the history. Sydney to... Okay. Johannesburg. No, that's Johannesburg. We're looking for Sydney to Santiago. I might be able to go through. Let's go flights. And let me see. Search for origin airport. So we're going SYD. No airports. What? Isn't Sydney SYD? Search for origin airport. Let's just go Sydney. What does it mean, no airports? What is it talking about? Am I completely backwards here? All right, let's get this one here. What is the flight from Sydney to Santiago? Flight number. Qantas. But go ahead, Dave. You were going to say something about QF27. All right, there we go. So we go here. You were saying something about people get confused on this flight. QF27.
No, just people. There's some people like Max Eigen just went off again recently saying that the flight does exist. We don't think it doesn't exist. There was a short period of time where when the flight first started, some flat earthers were saying it didn't exist, but then on that live stream when we had Max flying over, we proved that it does exist. And with his directions, his compass readings, Rob Skiba showed that it perfectly lays out with a flat Earth. I'm just saying that people say it's an impossible flight because there's a shorter flight. There's a shorter flight that takes the same amount of time. And, I'm NASA. I'm in charge of flight routes. I'm in charge of GPS. I'm in charge of deceiving the world. And I was like, oh, we got this flight. It's twice as long on the flat Earth, but on the globe, it should be the same distance, same time. What should we do? Jeran, what should we do? Take them slower, put them, put the one that has to go longer in a good tailwind, have them fly a little faster, take the other one, put them in a headwind, and make them land at the same time. That's all.
Why can't I grab this? Weird. Hold on, sorry. I just pulled up Google Earth, but it's out of my screen. Why is that happening?
Where does it go? Santiago to Auckland? Is that what we're looking for?
No, I found it. Sydney to Santiago. But what I was checking is if you look here. Oh, you guys, can you see this? I go back to OBS, see what you guys see. Yeah, so look at this flight path, though. Okay, that's nothing. They tell us that the. How do you get this down?
It's QF27.
Yeah, I got that. We already got that. We're past that, Dave. But look at the flight path here, and now look at what it is on. My Google Earth is so messed up. Why would it be above? Oh, here we go. Now we got it. Beautiful. Thank you. Now we got it. Now moving this over here. All right. Here's your Google Earth. Here's your flight. If we were to do, because they say all these flights take the Great Circle route, right? So let's see what the Great Circle route looks like from Sydney to Santiago. Sydney is going to be right there at those little G's, and Santiago is going to be over here. And you'll notice that if you're taking the Great Circle route, you're going way down by, where's Santiago? Right there. Okay, so this is the Great Circle route. Save. Doesn't matter the name. Zoom out. The Great Circle route goes way down here. Okay, well, look what they're showing. They're showing that this what? This is nothing even. So now planes don't fly Great Circle routes. They randomly go across what would be much longer of a flight than if they actually did this, supposedly, right? Anyway, that's not the point I'm getting at. What does this thing? Get out of here. Close. Do I have to have 7,000 ads up? Okay, so this flight here, though, here's the problem with it, is we just saw that it takes 12 and a half hours to get there, and it's 7,000 miles, right? So we can bring up a calculator and we can say, now this is what you have to believe if you're a globe believer. We know that there's 250 mile per hour winds going in that direction. Remember that. So if we go 7,000 miles and we're doing it in 12 and a half hours, 7,000 divided by 12.5 equals 560, which is about the speed of a plane, right? So that makes sense, except for the fact that there's 250 mile per hour winds. So now you have to believe that that plane, for whatever reason, is actually only going 310. So just for some reason on this southern flight, the plane is going way slower than any plane ever goes, and we're just supposed to believe that. Or do you think it could be that that flight that's taking 7,000 miles, now it's instead, let's say, okay, well, what if it's doing 11,000 miles, Jeran? Is that possible? Well, 11,000 miles divided by the 12 and a half hours that it takes equals 880. Well, Jeran, that's way too fast for a plane to go. Oh, but we forgot. It has 250 mile per hour winds. All of a sudden, the plane's going 630, which is below the speed of sound, and you're back to being in a realm of possibility. And I said 11,000, and I don't even think I believe that. I believe it's more like 10. So people keep latching on to things that aren't even realistic, like planes going way slower than they ever go in order just for what reason? Why not do that flight faster? It's only 7,000
Yeah, and
miles.
these planes are special.
Right. Yeah, just the
ones that do this.
Dreamliner.
How many layers of paint?
Right.
Extra
Layers
weird
of
paint do they have on
stuff,
them? And yeah,
composite materials. They've got all this. new
only a
stuff.
handful of pilots can make these flights.
Right. Exactly. What was it
Just
again?
beg the question and work your explanation off of that.
Right. And now this is why I believe that boats are the better indicator, because a boat cannot, at least as far as I know, gain that kind of speed. Right? A boat going from Sydney to Santiago, it couldn't be magically there and double the speed. I mean, it would mean like a cruise ship automatically, going 40 instead of 20. I don't know if that's really possible. Now, could it be possible? Could they retrofit a special one, or is there some sort of current that could get it there? Maybe. But it looks like it's about 12 and a half hours, Sydney to Santiago. And Yeah, you can read see if these all take that same route. I don't know. Yep. See, that one's cutting way across by like, where's like Easter Island? I don't even know where Easter Island is. Is it more north than that? Up here? I've just never seen
I don't know.
it that
It's
low.
so weird looking at this map.
Yeah, it is.
I've been looking at a map a lot lately. I picked one. I'm making an AE map, and now when I look at every map, I see differences. It's so weird that none of them are really exactly the same.
No, they're all different. And this tries to tell you what you'll notice here that because I'm not like a member, but here's what Bob did. Bob signed up for the site because we kept seeing this problem of them locking the true airspeed, the vertical speed. So he signed up, and every other flight, it'll tell you this information, but not this one. These ones stayed locked. So, or it wasn't locked, it was NA. It would show NA. So like we couldn't even get it. Because I mean, look at, here's your ground speed. Well, first of all, the ground speed going what does that say? 650. I saw it get as high as 650. What is the speed of sound at 35,000 feet? Isn't it lower than that? Or what? Do you know what the speed of sound is on speed of sound at? Let's just try 1 atmosphere.
Isn't it faster up higher?
Yes, but not by a lot.
Speed of sound is. Let's see here. Speed of sound. 767. So that's it. Well, then it's slower higher. The speed of sound of air is about 767 miles per hour or 1 kilometer. Yeah, speed of sound is, I think if you go higher that it would be less. So if you did speed of sound at, again, how would we know this?
Well, you can, if you, I'm trying to think of the right words for it. When you're measuring the speed of sound through water, and I guess I had it backwards. I guess it's actually faster in water because there's more median to
Correct.
vibrate to get that. But higher up, there's less air, so less wave propagation. So yeah, it would be slower.
So the speed of sound at 10,000 feet is 761 or 734 miles per hour. The ratio continues to get smaller until 37,000 feet, where it remains at 0.8671. Or is that the Mach?
So at thinner air, it goes slower. Sound goes slower.
Yes.
So we're at the top of Mount Everest talking to each other. Would you have like a delay? You'd see my mouth move before, like I'm standing right next to you.
I'm starting not to
I don't
believe.
know
I'm
if
starting
it's
not to
that
believe
much
any
of
of
a
this shit.
delay.
I'm not believing any of this shit. It just all seems so contrived and just bullshit that doesn't work. But anyway, if this plane is going, where were we at here? Back to the Qantas, not flight by airline. I lost what page I was on. This one. So it's showing a ground speed 650. But remember, I used to show before. Oh, there was a ground speed of 700. Did I see that? Yep, 726, right near the ground there. So I used to show before that if we got these to show up in the past and they would show true airspeed, we would get it up as high as 1,400 miles per hour. That's why they had to get rid of it. And I'm not saying that's true. I don't know where they were getting that number from. But we were able to see that before, and now they don't show that anymore at all. They won't show that. So people are very confused about this flight. They think it proves something. I don't think it proves anything. In fact, I think, and this is something, I wish I could go back further in time. Their flight used to show this. Because I even think people thought that but you know what? With this, we probably changed this, Dave, because this is kind of more in line with what we saw from Max Egan, huh?
Yeah, they said it went right almost over Antarctica, like way down there.
Yeah, I think
But-
that's what I used to too.
No,
Yeah,
Max
that doesn't
was
happen.
even farther north. No, Jeran, what proof do we have that that's the actual route that they're taking?
None except for this claims to be GPS. So the purple line is okay, I mean, look at the big difference there. So we're just talking about two flights. We're talking about this flight here, showing it go straight across here, right? And then if I just go to that last flight, which was down here, then it's showing it go way down here. So, and then...
Now, is that
You
going
drop-
from one city to the other and then vice versa, or is that going from the same city to the same city?
This is always going from Sydney to Santiago. You can go backwards,
Wow.
but it's a different flight number, I think. So you can.
That's a huge difference.
Yeah, that's ridiculous. And you used to be able to. I think if you go like here, if we go, so we want to go back the other way. You go Santiago. This should bring up all the flights from Santiago, and then we go to departures. Now it might not be in the right day. So we're going Santiago. Sorry, yeah, Santiago. We're looking for Sydney here. Show all departures. So this will get us going back the other way. So here's So find Sydney. I'll just go control find. SYD. Nope. So I think it is every other day then that the plane does that. Let me see. Load later. Oh, there's more. How would you see where Sydney is? I don't see it. Anybody see it? Tell me if you see it pass by. There's Sao Paulo. And the other flights that they don't do, Dave, is South America to South Africa. If they do, and I think it's one of the other bigger proofs. Let's see where we are here. I'm just trying to see if there's any Sydney. Control find SYD. Nope. I don't see any for Sydney going back the other way. I think it's because it takes like long enough for one day that then it's the next day that it goes back. So this is showing me, you can go earlier flights. Let's keep going this way, see if we can find it. But I think that flight is the one that takes a lot longer, right? So the flight going back takes like 15 hours because you don't have the wind. Or you don't have as much wind. And that's another thing they don't tell us, right? When we go to Bob's Winds, they don't tell you the difference in speeds between like 26,000 feet and like 45,000 feet because they just give you HPA straight from 250 to 70 to 10, but all the flight routes are between 250 and 70. So you wouldn't even see them. I don't know where that's at. All right, well, Sydney. Nope, they're not showing me anything Sydney here. Anyway, if somebody knows that flight number, I could punch that in real quick. But
can I share my screen?
You may. I'll look for that one too. Oops, let me bring up yours. I'm gonna stop sharing. Stop. Confirm. Stop. I am ready
So this is
for you.
Oops, you can see this.
It's a little. Oh yeah, now it was fine. It was a mess first. Yep, we can see it. Everybody can see it.
So from Brazil to Sydney, they stop in Tahiti. Now, why don't they just cut across the bottom here? But a Glober might say, well, why wouldn't they stop in California? That would be a straight line going straight across. You know what the reason is?
Because it would expose the deception.
Well, no. That also. This is actually a women's soccer team going to Sydney to play soccer, whatever. The reason they don't go to the United States or Canada, which would make more sense, is because the United States and Canada require them all to have U.S. or Canadian passports, and they could bypass that by going to Tahiti, which isn't that much farther out of the way.
Makes sense.
Yeah.
Now,
But they should be going across the tip of South America, skirting, going by Easter Island, skirting Antarctica, go by New Zealand, and land in Australia. That's a straight line. Crazy.
Johannesburg here. I just want to shoot this one. Yeah, the other one that they don't do is Johannesburg to Santiago, right? So that was one. Let me put that. I'm doing it on my map here.
I'm going to stop sharing.
Okay, I'll come back to this one. Share screen and my side. Okay, so I'm looking at the wrong one here. There you go. All right, so now you can see Google Earth. So I'm just looking at Sydney to Santiago. I'm sorry, Santiago to Johannesburg. This flight here, and that route is 5,700 miles. So it says on the globe here. But you watch every time, and actually we could even go. Let's go Buenos Aires instead. To change this. Oops. Clear. Buenos Aires is where? Right here? So this little alcove, I think. Or am I wrong? Am I blind?
I'm not sure.
Buenos Aires. Where's Era when you need him? Sao Paulo, Rio de Janeiro.
Oh, right up there near the top, I think.
Am I blind? No, I don't see it.
Maybe not.
Let me just type it in. It's easier than searching forever. All right. Buenos Aires. Argentina is. I was right. Oh, in that alcove. Okay, stop. So we're going from there. Buenos Aires to Johannesburg is going to be in here somewhere. If I can find it here. There we go. All right, so it's only 5,000 miles. Okay, so 5,000 miles. But you watch. If we look up any flights, they will all do this. And Dave, in a second, I'm going to have you bring back up your map, your flat Earth map, if you could. So what we're going to see is that every flight goes up here first and then across to down here, which makes no sense. Why would you ever go up and then down? But you watch, every flight does, and the reason why, Dave, pull up your flat Earth map and show us.
I got a different one that'll show you even better.
Okay.
So this one right here.
There you go.
From
That's
Santiago to Johannesburg.
Yeah.
Right?
Mm-hmm.
They stop in Senegal.
Right. Yep.
right? But if you look at that on a flat Earth, on a globe, it's ridiculous.
It's ridiculous, and they do that every time. There is no direct flights, and of course they can always get away with the excuse of, "Oh, there's not enough traffic that wants to go there." Yeah, right. Whatever you say.
Could they fly a direct flight? That they could do that if they have the right plane, right?
I don't know. I guess because I don't know the speed of the currents if you're going west.
Okay.
Right. But I mean, even south, I mean, it's just weird that there is no flights that go there. There's no flights that go from Johannesburg this way, I don't think, really.
I like the fact that there's no flights from northern location to another northern location that ever crosses the equator.
Right. So they never go south and then back up north, you're saying?
There's no, if your origin is in any airport in the north to the destination, any airport in the north, it never goes south of the equator because it makes no sense on, it makes no sense on a globe or on a flat Earth. But on the globe, it would be the same in the south. A southern location to another southern location, you would never cross the equator into the north. They do it all the time.
But guys, you need the globe to navigate, right?
Yeah, right. I always see pilots.
I don't think they're seeing Dave's screen.
I always see. No, they weren't seeing Dave's screen. Oh, but let me bring it up. Sorry, that's this one. Dave, go ahead, show it again because I wasn't showing the right screen.
I'm still showing, right?
Yep.
So here's they went from Johannesburg. They stop in Senegal and go to Santiago. It's pretty much a straight line. They went as far as they could before they got over the ocean to refuel. But look at it on a globe. It's absolutely ridiculous. And again, the blue line is the equator. So any two places, any two airports, pick it. Take a basket and list all the airports that are in the north. Pick any two. Never ever will one of those flights from a northern airport to another northern airport cross below the equator. And on a globe, the same thing should be true in the south. Southern to southern should never cross north, but we see it now. We see it all the time.
So I just brought up
this alone
is evidence.
Destroys the globe. Destroys it.
So
okay?
I just looked up Buenos Aires to Johannesburg flights. So I'm trying to find a flight here, and I'm going to see if you keep that map open because it's going to give me a.
This is Johannesburg to Santiago.
Yeah, I'm doing Johannesburg to Buenos Aires, which is just more on the east coast of South America. But I'm trying to see if what flights I can find. I'm guaranteed there's no nonstop, I would say. So this one has 2 stops. One stop in Sao Paulo, which I'll guarantee is north of Buenos Aires. And the other, let's see if we can figure it out. This is Santiago, 11-hour in Sao Paulo, but it says 2 stops. Where's the other stop? Let me see if I can select this flight and then draw it out for us, Dave, where that is. So, because where's, Sao Paulo is going to be kind of near Rio de Janeiro. So again, if you look at the map, it just makes sense that it's going, see where Buenos Aires is, how that's kind of like on the way exactly. Let me see here. So this flight is Johannesburg. Why does it say 2 stops and I only see 1? It's only showing me Sao Paulo. I don't know why I'm not reading this right. Here's this flight. Select. Yeah, it's just showing weird. It says 2 stops on the top. But there is no stop, so there is no non-stop flight from there. Buenos Aires to Johannesburg. Okay. That's going the other way. Let's see what it says. 2 stops, yes. Show details. Okay, so the first stop is at layover in Santiago. Huh? So it goes that way first? Never seen that before. And then what's the flight from Santiago to where from there? Santiago to... Yeah, I just see Brazil, but I don't see what airport. Anyway, they all do that, and if somebody can find something different, please point it out. Show us these nonstop flights that would exist in a real world, or a flight that goes across. Well, I guess you can't ask for that anymore. Can't go across Antarctica; it's too cold.
One of the things they do is they just make everything so complicated, just like before Fahrenheit and Celsius. Mixing it up, different tables say different things, and on flights. Sometimes they have these flights with special planes, and sometimes they have fake flights. They have flights that never fly. They just mix them all in, so you can never say, "Well, that flight doesn't exist." Well, yes, it does exist. There's plenty of fake flights in there. Flights that, if they ever do get booked, they just change them. They go, "Oh, well, sorry, you're not going direct. You're stopping twice now." So it's very difficult to catch them.
Yeah, this here says Sao Paulo to Santiago is a 4.5-hour flight. Does that seem right? Just one side of South America.
We're not seeing your screen.
No,
We're
I know.
still
I'm seeing
Dave's.
Dave's
Okay.
screen.
I was going to ask if there's a Sydney to Santiago flight.
Yes, that's the
I'm
one
gonna
we're looking
stop
at.
sharing.
Go ahead. I'm over on mine anyway. So I'm just looking now. I've figured out how to get these flights. So this is all I'm looking for flights from Buenos Aires to Johannesburg. But what do you want to see? Which one are you asking for? You said you wanted to see what?
Sydney to Santiago.
That's the one we were looking at before. So that one should be. They have the flight every other day. I'm guessing. Let me see. Sydney to Santiago. Oops, I said Sydney. SYD. Sydney. Okay, that one to Santiago. Let's search. And we get, it's going to be not very cheap. Sorry about my internet here. It's not the quickest. Hello. Let's get there. But again, you right away, there's going to be the flight that takes 12 and a half hours. So here we go. So this is, well, this says one stop. This has, look at this one goes to Houston. Wait, what? This says Sydney to Panama City. What is going on here? I said Sydney to Santiago. This guy's just making up. I'm going to send you here instead.
It's like, hey, we don't want you to look at that one. Look at this one instead.
Go here instead. Okay, Sydney to Santiago. We got that right now. All right, now bring up those flights. I don't know why it's just randomly choosing flights for me. And see if this one's any different. All right, so these are going to all be the. Why does it show one stop? I've never seen them stop. Okay, they stop in Auckland here. Stop in Auckland here. So this is the one, the Qantas Airlines, 12-hour, 30-minute nonstop. So this is the one that everyone says is the flat Earth killer. So these all have one stop, one stop, one stop, one stop, one stop, two stops. Let's see the one that has two stops. So this one goes to LA to Dallas. This one goes LA, Dallas, Auckland. So there really is just a rarity that you would find that nonstop. Looks like there's just this one flight. I thought it was every other day. Maybe they've shortened it since COVID causes a lot of problems. So maybe it's shorter now. But anyway, I just wanted to point that out. But I don't even know how we got on that subject. Just everybody always brings up that flight. And to me, it's like, if anything, it proves flat Earth to me. Because it's just that plane should not take so long to do 7,000 miles when you have the wind at your back. I'm trying to think of another flight. Is there any kind of 7,000 mile flight in the north that anybody takes? Or no? I can't really think of where you would go for 7,000 miles. I guess you could go this way to, you're not going to find flights to Russia. Like LA to over here, where do we get? Yeah, 7,000 is too far. LA to over here somewhere. So this is 7,000. I just wonder if their flights are a lot faster here. Where does that take us? Anybody know any areas in here? Uzbekistan. I don't think you can really find that flight. But anyway, I think that the flights in the south are definitely indicators that something is up. Is this one?
We don't see your screen, Jeran.
Yeah, you do. Oh, you mean you guys. There you go. There you go. So anyway, if anybody finds anything different, but I always find planes that, like we said, here's the Rio de Janeiro is going to be up here, right? So it is weird that these flights all are going there first, but when you look at it on the flat Earth map, it's right in line, meaning that these two are directly in line with South Africa. So that would make sense to me. But again, that's their baby. This is their one flight that they call the proof. And so those guys went Buenos Aires supposedly to, where were they going? Where were they going to land? Where they said the temperature, oh no, they were going South Africa to, they went here, supposedly. They landed this little island that's out here. Yeah, here. Mauritius? Yeah. This is where they started. Then they went to, supposedly, wow, so that's so weird. So the Great Circle route from there to Buenos Aires would be that, but they actually went more like, let me put a actual path in here rather than them do the Great Circle route, because we just saw that their path went from here down to here. They showed it crossing here, I think, and going like this. But really
absolutely. Yeah.
Yeah, but what they're saying they did was they're saying they went like this, here and path. They're saying they went like this. I mean, even that. So you're saying you went here and then turned directly and went here? I'm not even sure I would consider that circumnavigation. Like, what does circumnavigation mean? That you just need to, it's like running liners in basketball where you just have to touch the line and come back? I mean, why won't anybody fly across the damn continent? And this is why I challenged Neil deGrasse Tyson, who made a video about, we don't see. I said, okay, show me this flight. Show me the flight from Perth. I'm sorry, where's Perth? There. Show me the flight from Perth to Buenos Aires. That's the flight I want to see. That's the one that we tried to get the pilot, the guy Kelsey, who said, you could call me up and I'll do a chartered flight for you.
Yeah.
And then we tried to call him up and he's like, I'm not some travel agent. I'm just a pilot. Well, then you just made a video telling us that we could use you. So this flight here, no way. They'll never show you that flight because that one is one that you cannot do on a flat Earth map, in my opinion. I mean, how many miles did we say that was? Let me just do this one more time. So from Perth there to here is 7754. I don't think you could do that, and that's why they won't do it. Is because that's 7,000 miles, so they should be able to do it in like 13 and a half hours. But bring up, Dave, one more time your map, and let's look at that flat Earth.
Yeah.
Let's see it one more time. So that's 13 and a half, maybe they would say they could do that. I wonder if there's ever been a flight. So now look at here. If you try and take from, excuse me. We don't have a way of seeing Australia on this map.
On that one, I have to get another one. Hold on.
Okay, yeah, just get another flat Earth map so we can see it real quick. Because that's the flight that, would it convince me that the Earth is a ball? No, but it would be, because again, I don't think you can fly straight south. You're not getting any help from the trade winds. You're not getting any jet streams going directly south.
There you go.
And you wouldn't get any, right. So now if you look at that and look at where Buenos Aires is. Buenos Aires is all the way on the other side of South America. Can you see your mouse or no? Yeah, right there. So that flight to go from, and look where Perth is. Perth is on the other side of Australia. So you're talking about half the Earth. Oh, keep going to the right a little bit. It's all the way on the shore.
Yeah.
Yeah. So you have to get from there to the other, to there. I mean, how could you do that? I mean, that flight is going to be way too long for, at least as far as we know. And then they're going to be showing that you have to leave the place and be going directly south. Well, they're not going to be going directly south. They're going to be going directly east. So that's the flight to me that would be the killer, the biggest one, if they could ever even try it. And I don't think they'll even try it because that's probably, what would you guess, Dave? 25,000 miles if you had to go around to get there? I mean,
Pretty far.
Yeah, pretty far. Maybe 20,000 miles, and there's not even planes that claim to go that far, so without stopping. So anyway, that's the one to me that would be. Oh, people aren't seeing it. Let me change it over real quick so people can see it.
Got to be careful with that one. They might pull the double plane, double twin.
Right.
Switch.
Talk about that one. Yeah, and that's the thing, right? Here's what people don't realize too: is if this is a lie, then they will do anything to protect it. Right? It's not something you're just going to uncover. This is why I think that those, Globers who think that we say something about NASA and then they go to NASA and they find the NASA answer and they're like, "Oh, look, you idiots, it's right here." It's like, yeah, they're the ones we're saying are deceiving you. It's literally like I said the other day. It's like these guys are, if we see somebody robbing a bank and we're like, "Hey, look, Globers, look, that guy just robbed a bank," and they would run over and ask that guy, "Did you just rob that bank?" And he'd be like, "No, I knew that flat earther was stupid idiot. He says he didn't even rob it." It's like, yeah, you asked the guy who I said robbed the bank. So of course they're going to tell you they didn't rob the bank. You guys are running to NASA and getting all the official versions and then using that as evidence against us saying they're deceiving you. So that's not the person you need to go to. You need to actually use your head and use your mind and actually investigate things. They don't understand that. They think investigating NASA is looking what NASA says. That's not investigating anything at all. So now you can see this just to show where Dave was talking about. So here is your Perth. And how do you get to Buenos Aires, right? So you're either going to have to go all the way around here. And remember, you need to be flying over ice for, let's see here. Let's see how far that distance is. Let me save this. I know you can't see what I'm doing. I'm just doing it on myself here. I'm just going to check that distance across Antarctica from that point where it starts to where it ends is 2570. So, 2570 of that 7,800 trips, so 2,500 of 8, it's about 30%. So 30% of your trip needs to be above ice. So you can't even
But that's why they'll do it at night, so you can't see.
Right, which is what they did this one world orbit, right? So they can tell us that they flew over the South Pole, but they didn't have to fly over the South Pole. They could have just skirted the ice, and we would never know the difference. And this is the problem. And they can lie to you. And then why wouldn't they? Because it's their baby. They're not going to go out there and prove that they've been lying this whole time. They're going to do whatever they can to make you think the other way around. So again, this plane has to either get out here by the ice for 30% of the trip and then try and cut over here quickly. I think no matter what, that's impossible. They're just not going to be able to do it unless that plane magically goes, I don't know, 2,000 miles per hour. That's how fast
I
it would
think
have
that
to
one day they're just going to come out and go, you know what? You got us. It's flat.
We're running away.
You got us.
We're going underground now.
You got us.
We built a bunch of shit
Yeah,
while you guys were busy about
you got us.
And really, all you have to do to think like Jeran's saying to think, you have to think of them as the criminal.
Yes.
When police are investigating a criminal, they're not expecting to be told the truth.
Right. They're not assuming
Stop
the
it.
person they're
Yeah.
talking to is a saint.
Yeah, they
what
don't.
this
When the
is.
guy says, "Oh, I didn't do that," they don't just take their word for it. Ever.
And they have to remember that people are compartmentalized, and that I don't know if you guys saw, I was talking to McToon the other night on my show, and I couldn't even get him to admit that they don't. Like, I was like, well, how do they know that the neutron star weighs 24 billion pounds a teaspoon? He's, oh, they know. How? How? They look through a
They know.
telescope for weight? What do you mean? That we don't never been there?
Math.
No one's
Jaron,
ever,
math.
That's their problem.
Math.
Dave. That's their problem. This is what college is doing to children, is making them think that because some mathematical equations work out, that means that it's true and exists in the real world, which it's not. So this is the problem, is that everything that we've been taught is scientific or is going through the scientific method is not. And of course, what is something that doesn't go through the scientific method considered? Pseudoscience. So everything that we're being force-fed is pseudoscience. And in fact, isn't astrophysics by design, by its very nature, pseudoscience? Who is going
Yes.
and checking these stars? Who is measuring the distances? So I understand that we can use parallax on Earth. We can measure things on Earth. We can do these tests because we can go out and verify that what's being said is correct. With in space, you just are at the whim of whoever tells you what the distances are. You better believe it, because how are you
And-
going to prove it wrong?
On the globe, when we see too far, they go refraction. So they have their refraction index. So you go to Metabunk, you just slide the thing over until it matches. Look there, that's how much refraction there is.
Right. So
As flat earthers, I heard this, I forgot who said this, but I thought it was a great idea. We need the imagination index.
right.
So we should make a little chart. When they say something, we could slide the bar over. Oh, look, it's
You're
perfect.
Right. You're right. You can make
The
that
imag-
flight. You're right.
The
The imagination. index is-
imagination index.
That's a good one. That's quite good. Yeah, they just don't, and I don't know if they'll ever get it. That it's. Let me ask this question, because I don't know. Maybe you guys have the answer. Maybe you don't. Troubling Tribune. How is it that we have stars that are supposedly gas, and we've got planets that are supposedly gas, that exist in the vacuum? How do we show that to people? Let's say I became a glober tomorrow. I'm like, okay, I'm going to be a glober now because I see all the evidence. But then people start asking me questions. Jeran, you're now a glober? Explain to me how stars exist in space. Like, there's just no answer for that other than, just what I've been told. Because how would gas ever, there has to be some example, just one, of gas pulling to the center. But there is not. And we know that because we take a gas chamber, we put it on Earth, we release gas in the vacuum, and it goes in all directions. Why doesn't it get pulled to the Earth? If gas is affected by the gravity pulling, and the Earth has a strong gravity, then as soon as we release the gas in the vacuum, all of it must attach itself to the ground. If it doesn't do that, if it goes in every direction, then we have to assume that no matter what gas we put in space, the same thing would happen, meaning it goes in every direction, meaning that is the complete opposite of pulls into the center. So,
And they've been trying to do this for decades. It's not without a lack of trying. They've been trying to recreate nuclear fusion forever, since, the way they say it works in physics, and then with our technology advancing, like the ability to try to recreate a sun. If it were possible, we should be able to do it by now.
okay, so let's say that the sun, because I don't really understand the mechanisms that they would say would bring that together, but let's just talk about a planet, right? So we're told that the sun explodes or whatever happens, and there's some big old accretion disk, and then all the planets start forming. Okay, well, if mass attracts mass, which I don't even believe, but let's pretend that we just give them that one. Mass attracts mass. Okay, so the particles come together and they start creating spheres. Great. Now let's talk about gas planets. So now the same thing must happen. And I get they say that because mass attracts mass, right? So if mass attracts mass, therefore gas must attract gas. but we don't see one bit of evidence of that. Where has that ever been shown? I don't think it's ever been shown once.
The Magellanic Clouds.
Right. And, Dave, that's exactly the kind of thing that they'll say, right? They'll consider that evidence. You're like, no, just because you've saw something in the sky and said that's gas and that it's accumulating is not, we don't know that that's true.
I love how they have gas and dust in a vacuum. No problem with that.
None.
Here's somebody pointed this out the other day. You can take your telescope, your P1000, and you can get a pretty crisp, clear shot of Saturn and its rings, whatever they are. You get pretty in focus, clear shot. Same thing with Jupiter, right? So Saturn is 889 million miles away. Jupiter 778 million miles away, right? But when we look at Venus and Mercury, which are only 35 and 67 million miles away, they're fuzzy, blurry dots. There's no sharp pictures.
No. Yeah, that's a good point. Well, they would say it's because they're so much smaller, though, right? I'm guessing.
Do the math on the 67 million versus 778 million.
You got me. I don't know. Yeah.
It's 10 times farther.
Yeah. None of that
I never
works.
like saying go to the math when we're talking about the celestial objects, because all that would happen if we did the math and found out that there was some error is that they would just be like, oh, yeah, you're right. And then they just change it.
Right.
And say, well, that's what must be what it is then. And here's the mathematical proof.
Yeah, and they just assume things have been like discovered, or I guess people they're not smart enough to grasp what it means when we actually discover something or prove something versus things in the sky that nobody can ever go to. Right? I mean,
well, it's not even just the lights in the sky. That's only 4% of the actual universe. Right? Like there's stuff out there. We can't see it. We can't test. We can't feel it. There's nothing we can do to tell us it's actually there. But we got, why not? 96% is make-believe. The ancients are probably laughing at us right now. If they could come to this time and look around and see what's being said.
It's bad. I think that they would laugh at us for sure.
It reminds me heavily of the whole global warming debate or whatever the heck you want to call it, the politics around it, where they're like, oh, we have a 99% consensus that it's real. And then you go and look at it, and it's not really 99%. And there's all kinds of problems with it, and the data is actually completely contradicts. So, and it's literally you just extrapolate it out to all the other sciences, including the shape of the Earth.
Yes. All right, Zach, I know you've got a presentation to give. You want to kind of transition to that? I'm trying to think if there's anything else on that. I really just wanted to point out these guys saying that we go over the North Pole, and that is proof because they didn't find an edge. Like, I'm just wondering what possible model did they see that would lead somebody to say, oh, if you go over the North Pole, you would see an edge?
The Mercator model.
Yeah, what do they think? That's what they must think. They must think they think that we live on the Mercator map. That's what it must be. Or they think flat earthers think that we live on the Mercator map. There's actually only 2 flat earthers that really believe that. I'm not going to mention their names. But there are 2.
Great job, guys. Good research.
They're the real GLOBEBUSTERS, though, if you didn't know that. They've renamed themselves. You want to go ahead, Zach?
Yeah.
Go ahead.
Yeah, let me I'll share a screen, and we're going to take a look.
What time is it? Should we go? We'll go give it a little bit, and we'll go over to Rockfin.
Oh, what's going on? Okay, share screen.
Let me stop sharing.
Yeah, there we go. All right, so the Rectenna. Now, what is a Rectenna? Rectennas convert radio waves into electricity. And this is not anything new. This article is even from 2019. So they've actually come a lot farther in the last few years. But this was envisioned by Nikola Tesla. Wireless energy transmission, it was made possible in the 60s. The very first Rectenna was patented. And believe it or not, you probably have been carrying around a Rectenna with you for a couple decades at least. RFID chips in credit cards, in your, I don't know if they're in driver's licenses or not, state IDs. But yeah, the little RFID chips, we've all heard of them. the tags can use energy from the radio waves that are emitted by the reader to transmit back their identifying data. So the little RFID chip isn't just a chip, it has these wires coming off of it. And I'll show you what I'm talking about right here. Now she's going to pull this thing up out of, this is your RFID, or your Rectenna right here, or the antenna part of the Rectenna. And this is on, all she did was take a credit card and put it into some acetone.
It came out?
Yeah, that little spider thing, you can see it right here starting. That comes out of there. That's in every credit card. That actually allows, like it was saying right back here, when that little antennas, those little wires come within range of a RFID scanner, it actually picks up the radio frequency that the scanner is putting off and charges that little RFID chip.
So our credit cards are already basically powered.
Yes, they have power when they're within range of one of the scanners. They're actually picking up energy from that scanner, which then allows the chip to be charged enough to send the data that it has on it to that scanner. The really interesting thing, though, is that they're starting to do this in bigger things. Electronics, wearables, medical devices, and more. They've figured out a way to hack into the RF and the Wi-Fi, which are much smaller waves. The antennas needed to be a lot smaller, but they ran into an issue, something about capacitance, leaching capacitance or something like that. It was down here in the article.
Did you guys hear Trump the other day talking about how they're going to do these tracking of people? Have you heard that yet? I'll find it.
No.
I'll find it, but
God.
it's just weird. You heard it? Who said that?
No.
Oh, somebody. I'll bring it up because it kind of coincides with this, and I'm starting to think, man, this is weird. I think that their goal ultimately is to track everybody with a wearable device, mark of the beast, if you will. But it's also what I've heard is the reason for this movie about trafficking children that's come out is because the government loves to present a problem and then give you the solution. So what they're going to do is tell us all that all these children are being trafficked, which we know, and they're being used for sexual abuse. So what's the only answer is let us chip your children. This way they never can get lost, and we always know where they're at.
They'll be part of right here. It even says, it mentions that in this article, the Internet of Things. Mm-hmm. And they want everything chipped.
Mm-hmm. Once they do that, then they'll start really invoking their the rights that they passed, or I can't call them rights, really, the infringements that they passed several years ago, where they're like, it's equal responsibility, the parents and the state, to raise the children.
Right. I just remember that.
Okay, so the thing that changes this from being an antenna and makes it a rectenna, I believe I don't think it's the rectifier. It's hooking an antenna to this little thing. So they're taking the electromagnetic waves, your radio frequencies and stuff like that, and they're running it down the antenna, which is kind of like just what your radio would be doing, except it runs it into something else, not into a semiconductor, but it runs it. Oh, it was in here. I don't think it's a rectifier. We're going to get into that on one of the GLOBEBUSTER techs, how this thing works and what it's all. But basically what I wanted to show you here at the beginning is that this is possible. They're using it. They're planning on using it for a lot of things. If you go look up Rectennas, there's a lot of videos that show people talking about you won't have to charge your cell phone. Right. Maybe within the next decade. They're planning on having it implemented into all phones and things like that. You may need a little station that you could set the phone by, like put it underneath a table or something, and as long as that phone was within a few feet of where that sensor is, it'll just sit there and charge itself. That's what they're planning for here in the future with this technology, the Rectenna. Now, what I want to do
Kill them?
is what,
Oh.
yeah. If you've never heard of him, Parker Edmondson, a brilliant young man when it comes to electricity and stuff like that. And he's kind of, I think, just infatuated with Nikola Tesla in the 1920s. But he built his own Wardenclyffe Tower here in his backyard. It's got crazy hair. I'll play his voice just for a second here. I love his voice. Yeah, just really interesting young man. But he actually built this. I think this one was in Louisiana, maybe Texas, somewhere down south. And this is his Wardenclyffe Tower. He's explaining how he does it. Now, he does run, I believe, the voltage from his house to power it, but it wasn't, the Wardenclyffe Tower wasn't designed to collect the energy. It was meant to transmit it out wirelessly. So what he has the power coming in, and he steps it up and runs it into that machine. And then he has the ground, he hooks it into the ground. So it'll be connected into the ground. And what he's been able to do, he shared his, how to do it. This video just shows you how to build your own. He'll go through all the math. He's just showing you, and it's really neat. I learned a lot from this young man. It has to do with how many revolutions it goes around, how long the wire is. So you really have to know your diameter and things like it's not as simple as just wrapping a wire around. You have to do a little bit of math. But he had someone do this, I believe, up in Michigan. They had built one of these. And yeah, here's him at a very young age. It is this video, 918 miles away. He transmitted electricity to his buddy. But here's him at a very young age just talking about a Tesla coil.
Wow.
This is what, children at these young ages can be taught this stuff. How all these Tesla coils work and this and that. And
who does he work for now?
I'm not sure. I know he does a lot of YouTube videos still.
Mm-hmm.
And it's not always about electricity. He buys a lot of things from the 20s. He has a car from the 1920s. All his furniture, his oven is from the 1920s. And he shows you how to live like they did back then. Yeah, it's really interesting. But here he is. He turned on his, and he's just showing how, even when it's not hooked up, he's just carrying a fluorescent light around, showing how far it'll light up away from that emitter that he has going there. And lighting up a little light bulb like that. And then his buddy is 918 miles away. Right here. Yeah, the video is real small. It's not the greatest video.
I'm curious of how we confirm it.
Mm-hmm.
Well, yeah, that's the thing. I think he gives out, because he doesn't live where the transmitter is at anymore, but he lets people know when he's going to turn it on. So what you would do, you would have to go back and watch this video here, how to build a receiver coil to receive my wireless electricity. It goes through the math and everything on how long it has to be, down to the 1,000th, or is that 10,000th of an inch? Yeah, it tells you how many times you have to wrap it. Okay, it's quite complicated, really. Now, go ahead.
Sorry, I was just reminded of the pylons out in the Midwest that go to nowhere and and have the wires between them, and I've always wondered if those are generating their own electricity.
Well, yeah, that's kind of the idea that I have. Now we're dealing with really short amounts of wire. He's not sending a whole lot of power. It's actually, it's a fair amount. I mean, it's coming out of the outlet right out of the wall. It's not like it's coming out of the power station. He is stepping it up a little bit with the transformer and things like that, but he's not really generating all that much power. Now, the Earth has its own resonant frequency. It's RF. We call it the Schumann resonance. And, he's dealing with hundreds of thousands, kilohertz and stuff like that, really high amounts of electricity. Well, the Schumann resonance is between 3 and 25 hertz, not kilohertz or gigahertz or megahertz, just flat out hertz, which is a really, really long way. When you're talking about wavelengths of these RF waves, the shorter the wavelength, the amount of hertz, the longer the wave is. So to do what I would like to do, it says here, it goes from Nagansenk, Hungary. Sorry if I butchered that. It's a small town in Hungary, and one in West Greenwich, Rhode Island. So the distance between that, 6,630 kilometers. So that's the length of the Schumann resonance. That's probably 7.83 hertz, I believe, is the strongest one and the one they're most likely measuring. So you take that distance, you go to miles, it's like 4,119 miles. So what I would like to do is consider this thing right here as the Earth. Because the Earth is putting off power. It's putting off its own resonant frequency, just like this device right here is. Now, if we take, instead of building a small one, to match his here, let's see, I forget how long of a wire he said it would take here. 395 feet is the distance that the wire needs to be. So instead of doing 395 feet to pick up his small amount of energy, what if we had a wire that was 4,119.691 miles long and then hooked it up to a Rectenna? Would we then be, I want to know how much energy that would be. If it was a really small amount of energy for some reason, which I don't believe it could be, I could see that. You wouldn't use this to just harness Earth's energy. It'd be pointless. But, and you think 4,119 that's a lot of wire. Nobody's going to use that much wire to do something like this, right? That'd be crazy. Well, there's 24,000 miles of wire in the Sears Tower alone, or the Willis Tower, 6 times as much. So they could already be doing this in all reality.
The little boy, his 3-year-old little boy.
Sorry.
But yeah, that's my idea. Take this, what we already have, carrying around with us all the time, this short amounts of wires that pick up, smaller amounts of energy. And I want to build a Rectenna that is enormous. Just huge. 4,000 miles of copper wire, one copper wire. And see what happens. I want to hook it up. I mean, it doesn't really need to be the 4,000. I think 25 hertz is also a pretty strong frequency you could pick up. But I think this is possible. If it's because electricity and magnetism are scalable. If you can do it on a small level, like they're already doing, then we should be able to do this on a mass scale, which they already could be doing, really.
Well, yeah, they could be tracking us through the credit cards.
Oh yeah, for sure they are.
Has your name
And your phone has an RFID chip. I mean, we put it in to turn it on, right? You have to put in the little chip into your phone. That's an RFID chip.
Great.
The Rectenna is just wrapped around it in a little circle, or they have different ways of doing it, of wrapping that little wire around it. And as long as it's not touching each other, it works as an antenna.
It's kind of
So
friendly.
yeah, it's scary. What they can already do and have been doing for a very long time. But I say we take that technology and let's get some free power out of it. I don't see why it wouldn't be possible for somebody with the funds, to build something like this and get some real power out of it. I mean, this is zero pollution. Getting the energy from the source out to you. I'm not sure about the pollution cost of blah, 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 any of that, but this wouldn't be having to burn anything. You wouldn't be waiting on wind or waiting on the solar. You don't have to have clear days. This is a constant thing that's always happening. It's a resonant frequency that is always there.
Hey, Dave, is it true we don't know how solar panels work?
It is true that they don't understand exactly how they make electricity.
Wow.
They have a theory that a photon knocks a boron molecule out, and then it lets an electron float in, and it's a convoluted global theory, but they don't really know how it works. So the question is, who invented it? Some guy here, or is it just old world technology?
Right. They say that they don't know how planes fly.
I don't believe planes fly the way they tell us. I think it's an electrical lift.
Well, because
is it called the Bernoulli effect or something?
Well, that's what they tell people is the truth. They say because the shape of the wing, that the wind goes faster over the top than it does the bottom, which causes lift. But the problem with that is planes fly upside down. So right away it debunks.
Yeah,
that.
I always had a problem with that.
Yeah,
I always had a problem with that.
And there's planes with wings that are designed to not use that principle as well.
Yeah, I'm looking.
They're symmetrical on top, as they're the same top and bottom.
It's funny, huh?
So I've been thinking about this, just how we are looking into the theory, the provable, scientifically repeatable, testable theory that electrostatics cause the attraction down. When the lightning strikes, things go flying in the air. Maybe it's because it changes the polarity of the ground. When airplanes fly, their wings, electric charge changes, and they're literally they're levitating just like the silent drone levitates, but they have to do it while they're moving.
I'm just putting this on the screen real quick. It's because people will never believe me if I don't show you that it's true.
Show us also.
Oh, let me get back to Skype and share screen. When I heard that, I was like, that cannot be true. And I went looking at it, and sure enough, what do you know? So this is from Scientific American. So this is not anything, and no one can explain why planes stay in the air. And it's just talking about that on a mathematical level or on an explanation level or scientific level, they don't know. There is no agreement on what generates the aerodynamic force known as lift. There is no simple one-liner answer to this. He told Times, people give different answers to the questions, some with religious fervor. More than 15 years after that pronouncement, there are still different accounts of what generates lift, each with its own substantial rank of zealous defenders. At this point in the history of flight, this situation is slightly puzzling. After all, the natural processes of evolution, working mindlessly at random without any understanding of physics, solved the mechanical problem of aerodynamic lift for soaring birds eons ago. Why should it be so hard for scientists to explain what keeps birds and airliners up in the air? It's just something you would think. Everyone assumed we've got massive planes carrying 250 people, thousands of miles, that they know how, but they don't really know. There's no explanation for it, like scientific explanation.
They don't know airplanes fly, but they do know how bumblebees fly.
Do they really know? Electrically?
Well, they speculate that it's this whole frequency thing, and I think it's not that dissimilar for an airplane. But that's just me thinking. What the hell do I know? I'm a flat earther.
And look at Scientific American knows, but by themselves, equations are not explanations, and neither are solutions, and neither are their solutions. So it's like, again, this is the problem they've taught everybody, that if we can do an equation, you do this equation, then it must mean reality. But it's not an explanation.
No, not at all. And that's why I picked Walter Lewin.
Right.
When I was going to pick somebody to learn from, I read that quote from him and said, if you only know the equation, you know nothing. And I was like, that's the person I want to learn from.
Right. Zach, that's not even Walter Lewin. Come on.
Yeah, it is. What are you talking about?
Thank you. That was just for me and Jeran.
That was, yes.
Oh,
You took that out. You changed it. And put a little
Big
note.
Toon did a whole like he's obsessed with me. I think he's in love with me.
Here's the
But he
picture.
had when I showed the slide of Walter Lewin, and he goes, "That's not even Walter Lewin," and it was.
Right. Isn't it like where's the homepage? Because I think right here it shows you're number one, Dave Weiss, aka point by point claims refuted. But down here somewhere, there's a picture of Walter Lewin, and it said, and Dave gets it wrong. He thinks this is Walter Lewin. So I messaged McTinnis.
And it's
"That is
Walter Lewin.
Yeah,
It's just Walter Lewin.
Yeah, it's just him. It's not even didn't take. You could literally search his name, and one of those pictures that Dave showed shows up. And
That's exactly what I did to get the picture.
I figured that. Where does he talk about it? I thought he said, all right, here we go. No, in the previous version of this page, I claimed that the photo of Walter Lewing, and he says his name wrong, that's not Lewing, that Dearth used was not Walter. After Jeran challenged me, I investigated and discovered I was wrong. It is a photo of Walter. Here's the original source. There you go.
Oh, he's such a good guy. He
Oh,
really
such
is. We got to let him in with open arms.
I think what we need to
When
do is,
are you back on with him again?
I don't know, like in a week or two. But I think we should go through point by point until this entire page has to be taken down. That's what we should do. Just keep going after him. Saying,
That would be fun.
This is wrong. This is wrong. Here we go. What did Dave lie about? Dave lied about what Buzz Aldrin said. Dave.
Is Zach done with his? Are you done, Zach?
Oh, sorry. Go back there. Can we go back to Zach? Sorry.
yeah.
Oh, that was the end of your presentation?
Yeah, that was it. I just wanted to show everybody what a rectenna was, and really, I want to build, or someone, I want to know how much power we were going to get from the Earth, the resonant frequency of the Earth. It's there.
So
you can measure it.
I've started electric culture, and I've noticed changes, not anything scientific, just as far as when we put them in from then on, it was like things have just been growing like crazy. Should I be able to attach a meter and pick up an electric current from those copper spools or spirals? Do you know?
Yeah, you might pick up a little bit of a difference. I know the copper is touching the wood, right, which is touching the ground. So the copper is still grounded at the top. You're not going to get much of a difference. You really need the copper to be up in the air by itself, or with a something more of a, what's the word? Oh my gosh, I'm having a brain fart.
I don't know.
Just something that stops the energy from flowing. You have, you have your conductor, and then you have, oh my goodness,
Insulator? No.
Yeah, insulator. Thank you.
Okay.
Jeez, oh Pete. Just an yeah. You need the copper to be insulated so it's not grounded. And then if it's being held up by an insulator, then you will be able to measure a voltage difference between the top of the wire and the bottom of the wire. But yeah, it all has to do with how far away from the actual ground it is. I mean, the top of a tree is still ground. Because the tree is touching the ground, so the electric field curves up over that tree.
Let's move over to Rockfin.
I've got a big tomato garden going with a bunch of electroculture, and if anything, the worst is it looks cool. If it does nothing else,
it does look
looks
cool. It does look cool. I'll give you that.
It looks really cool.
Yeah, and it was fun putting them together. I enjoyed it, and the copper wasn't too expensive either. So, all right, I'm going to put this in the YouTube chat. Thank you very much, everybody at YouTube, for joining us, and we are going to head over to Rockfin, where we can talk like big kids. And there you go. And I've got a few things to talk about over there, but I wanted to kind of bring up Hubble's law. But because what do they tell us that a law? What is a law in science? That every bit of evidence leads to that, or something? What do they consider a law in science?
Well, yeah, a law is something that can't be tested experimentally. And then there's natural law, there's ideal laws, there's different kinds of laws. Natural laws are the ones that we can test, and they always happen all the time, no matter what.
So like Hubble, when they say Hubble's law, what are we supposed to glean from that? That it means
that's probably a made-up mathematical construct, most likely.
But what do they try and teach us? What is a law in science? I'm just going to look that up and see what the definition is. Does it mean that it's a scientific law are statements based on repeated experiments or observations that describe or predict a range of natural phenomena? Okay. Because they say that Hubble's law is that everything's moving away from us, but that's not being seen. So I don't understand where they get it. Thank you, everybody. Thank you, Matthew Scattergood. I didn't check if there's any super chats. Is there any way to check? I'd have to go in the back room. Let me just make sure I don't want to miss anybody? Let me check that real quick. We got to go to YouTube Studio. All right. And do you guys have anything you want to talk about specific over on the other side? Let's see what we got here.
Well, I know we'll be free to talk about whatever we want. I love that.
Which is so much better. Let's see here. Super chats. We've got supers. What is today? See all. We are at the 9th. 7-9. Now I don't even see dates on here. Okay, no, this is all last time.
I saw there was one Rockfin super chat.
Yeah, I'll get those over there. I'm just checking if there's any other. Oh, wait, you can scroll over. GLOBEBUSTERS, July 2nd. Okay, none for today. Thank you guys very much. We are going to head over to Rockfin. And hopefully what I think was happening, Dave, is everybody's waiting to get to Rockfin to send tips because they realize they don't want to send 30% to the beast, which makes sense.
I get it. That is so good.
People are
and
learning.
Anybody that's just coming over now, you should send $10 over as a penalty for being over on YouTube. You should penalize yourself weekly.
Beast penalty, yes.
Yeah, you should penalize yourself. And I'm going to show I would like to show you a preview of the update that's coming on the app very soon.
Nice. All right, we'll see you guys over there. Thank you very much for being here. We will be back next week again. I believe Austin will be at the helm. That is GLOBEBUSTERS every Sunday, 12 noon Pacific, and also Thursday nights at 7 Eastern.
Yep.
Okay, good. Just make sure.
Also, if you missed the link in the chat or you're on your mobile, just open up your Flat Earth Clock app and a GLOBEBUSTERS pop-up will jump in front of your face. Click it, and then you're over at Rockfin for free, listening for free with no obligation.
So I'm just reading. Somebody says here, with gliders, shape of the wing creates low pressure above the wing and high pressure below, creating lift, wing loading, AOA. Yeah, but the problem is that planes fly upside down. So if you're just saying it's because of the pressure in the wings, then planes wouldn't be able to fly upside down. So that's kind of the whole thing, is that people think they know, but the actual truth when you dig down to it is nobody knows, which is a crazy thought.
Yeah, the whole upside down plane thing has always bothered me, and I've just never thought it through. It's like there's something else.
Yeah, something else. All right, and again, go to the Scientific American article and read it yourself. It says right on there that we don't know how planes fly. All right, see you guys on the other side later. YouTube, you've been fun and all that stuff. All right, we're done there. All right, we can now talk freely.